We're gonna learn further. So in supervised learning, there are two types of machine learning. First is regression, second is classification. So if you are an Indian PCM student, you know about JEE, right? So there were two types of question in JEE. First, like A, B, C, we gotta take one, and the second part of the question was to write an integer, to give an integer value. It was an integer value, but think of it that you can also give decimal part. So there were two type of question in JEE, right? First was to check from the tick from the MCQ part. Second, where you gotta give a number in decimal or without decimal, whatever. So exactly this same thing is happening here. There are two types of supervised learning. First is regression, second is classification. In regression, you get a number, a numerical value, a continuous number, and in classification, you get an answer out of all the options you give to the model. For example, you are asking, I'm doing way too much, right? You are asking model, providing a picture that whether this is a cat or a dog. So if this is known as classification, you are giving choices and the question is a picture and what is it, and the options are cat or dog. So model will choose one, and this is known as classification. So there are two types of classification: multi-class classification and binary classification. Binary, as the name tells, that there are only two options, yes or no, cat or dog, 1 or 0, that's it. And in multi-class classification, there are many options: A, B, C, D, frog, crocodile, tree, or apple. These are the options. Tell me what is it. So this is known as multi-class classification, where the model has limited options to choose from. And in regression, now in regression, the value, the output is a continuous value. For example, tell me how much happy I am in percentage. So from 0 to 100, there are innumerable amount of possibilities. Infinite numbers are present in between 0 to 100. No, it's not like it's 0, 1, 2, 3. There are also 0.2, 0.222, 0.5, 0.5689. So there are infinite numbers between 0 to 100. So you get a continuous value that, oh, you seem 69% happy. So yeah, this regression, you get a continuous value. These are the two types of supervised learning. Let me give you some example of algorithm that you use in supervised learning. Linear regression is the most famous one, which gives you a line between linear relationship between input and output. Usually there is just one dependable variable and one independent variable. What does that mean? Dependable variable is something that depends on dependable variable. For example, if there is a sun, it will be a morning. If there is not a sun, then it will be night. So sun is independable. It will come and go whenever it wants. It doesn't depend on anything. But morning depends on whether there is sun or not. So independable variable is sun, dependable variable is time. So yeah, in linear regression, a line is made, linear relationship is made between dependable variable and independable variable. So using the behavior of independable variable, we tell how the dependable variable will act. So if we look and we have like the data in our mind that if there will be sun, it will be morning. If there will be not a sun, it will be night. And we look out at independable variable. Oh, there is sun. So we will figure out what will be the value of dependable variable. It will be morning. So this is linear regression. Now logistic regression is linear regression with a curve. Wait, I'm wrong. That is polynomial regression. Shit. Sorry. Logistic regression is 0 1 0 1 0 1. It is used in classification. It's just a regression in name. It kind of look like sigmoid function. I'm sorry for being a bit technical, but yeah, it is used for classification. It gives 0 1 0 1 0 1 possibilities. This is how the graph looks like. Next, clustering. That's what I had talked about yesterday. Like how we were grouping customers from low income group is different, high income group is different, low customers who do low expenditures, higher expenditures. We had done that yesterday. Now the next is cross validation. Cross validation is used to check the accuracy of supervised model on unseen data. So what happens in cross validation? I'll tell you later. Actually, this will come later. Dimensionality reduction. This is something interesting. I don't have much knowledge about it. I just realized that now, and I will research about it and tell you tomorrow. But let me tell you what is it exactly. In dimensionality reduction, the thing is, if there is a model, okay, which takes input of 4, like there's an algorithm which takes 4 input, okay, but you have data where there are 15 variables on which your dependent variable depends on. So what will you do? How will you fit those 15 variables into a model which takes only 4 inputs? So how will you train the model using that exact algorithm? So dimensionality reduction is a technique through which you can reduce the dimension. There are 15 variables I'm talking, right? So it is called that 15th dimensional thing is right there. So you have to reduce the dimension of those 15 dimensional thing. So using this technique or some wait a second. Using that technique you can reduce the dimension. Shit, I should research about it and tell you tomorrow. Okay, now comes the most best part. I love this. So once you have collected the data, okay, and dimensionality reduction was very sudden topic. I don't know why I've written there. I just used to like read documentations, and if there used to come a word that I didn't know about it, I used to search about it and write the definition, understand about it later when it's time come. So I wrote some definitions here. I don't know why, that was really out of nowhere. So yeah, So once the data has been prepared, like you have collected all the data, okay, you train the model, okay. So what happens when you train the model? The model learns from the data, like okay, this is if these things happens, this will be the nature of dependable variable. If this is happening, this is how it will behave. If Pragati is happy, she will eat ice cream. If Pragati is sad, she will eat chocolate. So if you give input about, oh, Pragati is feeling sad today, what should I give? So the model will give output, oh, why don't you offer her a chocolate? So this is how machine learning works. And if you tell, okay, chocolate isn't working, then the nearest output, okay, why don't you try chocolate ice cream? It will give it like this. So this is what happens when you train. But during training, we have to make sure that two things doesn't happen: underfitting and overfitting. What is underfitting? Underfitting is when model cannot capture the essence of the data. For example, you're telling Pragati eats ice cream when she's happy, chocolate when she's sad, and she eats nothing when she's angry, and if she's anxious, she'll eat anything, and if she's feeling nothing, she will eat kurkure. Okay, you give 5 input. Think that your model is very good. Okay, only 5 input of data is very big for it. Okay, like enough for it. Satisfied. It's only about Pragati. The model is only about Pragati. So you give this much input. But the model couldn't take the essence of the data, like couldn't understand what is happening in this data. And you ask, what does Pragati eat when she's angry? It will give a random value, like it doesn't matter. It will be like, she eats ice cream. So if you give ice cream to the angry Pragati, she might just throw it away on your face, like. So the outcome will not be desired because it couldn't really understand the data properly. This is known as underfitted model. Like it wasn't able to train on that data properly. Sorry, no Hindi. Overfitting learning. So what happens in overfitting is the model learns the data way too much, like very nicely, so that when a situation arises about something that it wasn't taught, it won't behave well. For example, what example should I give? Overfitting. Okay. There is a model who is taught to detect cats. And it was given millions of images of cats. Now that model can see cat everywhere. Literally. The model is seeing cat everywhere. The model is overfitted so much that even if you show a dog to that model, it will be like, it's a cat. If you show a parrot, then also it will say it's a cat. That it has been overfitted. Like it started loving cat. It started loving the data it was provided. This is known as overfitting. So you have to make a model which comes between underfitting and overfitting. It doesn't go either of the side. It has to remain in the middle, which is kind of difficult. And how do you do that? By tuning the hyperparameters. What are hyperparameters? Let me tell you. Hyperparameters are defined as the parameters that are explicitly defined by the user to control the learning process. The value is set before the learning algorithm begins training the models, and their values cannot be changed during the training process. For example, पापा आवाज कम करना थोड़ा. My nose is still blocked. So hyperparameters are parameters provided to the model about how it should be trained. For example, when you're learning about something, an answer, you read the answer, Lata was a girl. So when you were small, how you used to learn Lata was a girl, Lata was a girl, Lata was a girl. Her mother name was Pushpa, her mother name was Pushpa, her mother name was Pushpa. So you used to repeat things, right? So you had set a number, like I will repeat everything 3 times, and I will learn everything. So these parameters, such parameters are also given to the model, like repeat everything this many times and you will learn it. So some parameters are given, not just this parameter, more parameters are given, and these parameters are called hyperparameters, on which the training process tends. And if the hyperparameters are correct, the training will happen nicely. If they're wrong, it will fall either on the underfitting side or on the overfitting side. So you have to tune the hyperparameters correctly, and once the training process begins and it is on, you cannot change the hyperparameter. You can only and only change it again when the training process ends, and you have to try it again. Or you can just explicitly end it forcefully. There's always an option like that. I hope so it always remains like that. Oh, it's a 17-minute video. Oh my god. Should I just end it? Let me tell you another interesting thing. Oh, I have more types of AI. Not more. It's actually just the basics. Okay, this is nice. Let me tell you. I will tell you tomorrow actually. Never mind.